Solving linear inequalities. Inequalities often look a lot like equations, and we need to solve them just like we solved equations in the past. Solving inequalities fortunately works just like solving equations. We're going to do the same thing to both sides. We're going to do opposite operations to clear unwanted numbers. It is going to be identical. Almost. First, let me start you with a simple example. 3x minus 5 is less than or equal to 4. Just like we always used to balance on the equal sign, we can balance on the inequality sign. So we get rid of the minus 5 first, adding and subtracting first by adding 5 to both sides. That gets rid of the 5s. So 3x is less than or equal to 9. Dividing both sides by 3 to get the x alone, and x is less than or equal to 3. We can then express this answer as a picture of solutions, where we got the number 3 there to the right of 0. X is less than or equal to, so we have a solid dot. And because x is smaller than that, we can shade off to the left. And we've got a picture of our solutions. We can also represent that picture with interval notation. Negative infinity to one side and 3 to the other side. Square bracket for 3, curved bracket for the negative infinity. And so the solutions are represented with everything from negative infinity up to 3 with a square bracket, because it's or equal to 2. And we have solved this inequality that any value between negative infinity and 3 will make a true statement in 3x minus 5 is less than or equal to 4. Just like equations. Almost. There is one little difference we need to be aware of. That one little difference is whenever we multiply or divide by a negative, we must flip the inequality symbol. For example, we have the true statement 3 is less than 6. If I were to multiply both sides by negative 2, we would have a negative 6 and a negative 12. However, to be true, negative 6 is now closer to 0 than negative 12. Notice that inequality had to flip directions. It now opens to the left and points at the right because we multiplied by a negative. When we multiply or divide by a negative, we must flip the inequality to keep it a true statement. Don't be this lady who forgot when she divided by negative 2 in an inequality, she forgot to flip the sign. You want to be this guy who remembers to flip the inequality symbol when dividing by a negative number. So, here's an example. It solves just like an equation, except for we know if we ever multiply or divide by a negative, we have to flip the symbol. First, we get rid of the standalone number without the variable by subtracting 5 from both sides. So negative 2x is greater than 11 minus 5 is 6. Divide both sides by the negative 2 to get the x alone. But notice what we've done is we've divided by a negative. So our inequality is going to flip directions. Now it's going to point the other direction. So x is now less than negative 3. We can graph it just like always. Negative 3 is over here to the left of 0. Strictly less than, so it's an open dot. We want smaller values, so we shade to the left. And we could also represent that with interval notation, going from negative infinity to 3. Because it's an open dot, we're going to do a curved parentheses. So a lot like solving regular equations, we just are able now to graph a picture of our solutions or give interval notations. Just keep in mind the only difference, and this is important, if you divide by a negative or if you multiply by a negative, the inequality must flip directions. Let's do one last example before I let you go. This one has the variable on both sides, but just like regular equations, we can take care of that by moving the 2x over to the other side by subtracting it. And if I do it on one side, I have to do it to the other side. 4x minus 2x is 2x. Minus 5, still greater than negative 7. Get rid of a part without the variable, the minus 5. The opposite is a plus 5. And 2x is now greater than negative 2. Since that's 2 times x, we'll divide both sides by 2. And x is greater than negative 1. Notice this time I did divide by a positive. Because I divided by a positive, I didn't have to do anything special with the symbol. So here's 0 and negative 1. We can graph that with an open dot at negative 1. X is greater than, so we'll shade the greater numbers off to the right. And we can also express that with interval notation, going off to infinity with a curved bracket at negative 1. Curved because of the open dot. This tells us that every value between negative 1 and infinity will make the original inequality a true statement. Pretty straightforward. Linear inequalities are just like regular equations. You balance on the inequality symbol. Just be careful if you multiply or divide by a negative. Be sure to flip the inequality. Take a look at the homework. Let your instructor know if you have any questions, and good luck to you.